Today I'm working on a excavator transmission control unit. The unit stopped working. It's from the same excavator that I worked. I posted a video about the hydraulics control unit that I repaired, and this one from transmission is damaged too. If you saw that video, I said that the wiring harness was damaged and it was a short circuit. The harness is replaced, that hydraulics controller electronic is repaired, and I need to fix this one too. I already took a look, and somebody actually worked before on these MOSFETs. I can see some soldering, that's not factory, and I've done some quick measurements. On the board inspection, we cannot see anything burned or cracked or discolored, but there are some short circuits on the board, and I will show it to you. Okay, so we have a short circuit on this diode. Let me put my multimeter in continuity mode. Okay, I already desoldered that diode and I test it right here on the bench, and it's good. So maybe anything else, it's a short circuit. We have short circuit here, we have here, we have on this capacitor. Let me show you. Here we have here, we don't have a short circuit here. Let's test those. Maybe no, we don't have here. So something in that area maybe shorted out. No, let's test this one. No. Okay, we have short circuit on these three capacitors, this diode, and those two capacitors, 1 and 2. And right now, for us to see what's the real component, what's the real broken component, we have to inject voltage on this diode. I'm gonna inject voltage on that pin of the diode because this one is ground. Actually, let's measure to see. If I put a probe on the ground and on this diode, we should see 0 ohms here. This is the ground. We have 0 ohms between this and the ground, and here we have 37 ohms. So it's not that short. Okay, I'm gonna solder 2 wires because I want to inject voltage on this diode. I'm gonna solder ground wire and 12-volt line wire. This is a fine tip. Okay. I think it's enough. I'm gonna put the ground here, the ground clip. I'm gonna set the voltage injection tool to 1.5 volts. Okay, I switched on the thermal camera just to see. I want to monitor the board when I'm injecting voltage to see if anything gets hot. And I'm gonna inject voltage in 3, 2, 1, go. Okay, this is the MCU. I think nothing gets hot on this side of the board. Let's flip the board. Nothing. I think I'm gonna increase voltage. I increase voltage to 2 volts. I can see some current drawing on the box on the voltage injection tool. And what we see here are reflections of the aluminum. So right now nothing is getting hot on the board. Let me put the macro lens on to zoom in. So maybe it's the big cap, this one from here that we measured before. So right now we cannot tell which component is the source of the problem, and I really have to guess. We know we have some short circuits on these SMDs capacitors, and this is an electrolytic capacitor. They usually fail, and I'm gonna take it out, and then I'm gonna remeasure for a short circuit those components. Okay, to take this capacitor out, I'm gonna use my vacuum station. So I'm gonna use my vacuum station along with the hot air station to help the board to heat. But I need to straighten these pins. Just like that. The microscope is in the way, and I cannot use the vacuum station perfect vertically. And the pressure cannot drop here. Suck that melted solder. Okay. Okay, the microscope was in the way. And right now the capacitor is desoldered. And I need to take it out. Yeah, it's glued. It's still hot. It's out. Let's quick measure again. I'm gonna measure from here to here, and we still have a short. Okay, here we are 1 day later. I worked on this again on this unit, but the OBS software crashed, so I don't have it on video. This is what I did. I desoldered that capacitor. I took it out of the circuit. This one too, and this one here. Let me show you with the tweezer. This one, and this. So none of them is faulty. and I desoldered this capacitor too, because I thought that it was faulty, but no success. And then I increased the voltage on the injection tool, and now I can see this getting hot. This is a transformer coil. Let me show you what I mean. Let's plug the thermal camera. Okay, so this is the transformer. I'm gonna inject voltage in 3, 2, 1 now, and you can see it's getting hot. This is the MCU. I'm gonna take it out of the circuit. I'm gonna desolder that transformer, and then I'm gonna measure again for a short circuit. To desolder this, we have to desolder 4 pins. Let's measure again and hope for another result. And we still have a short. Wow. 41 ohms. 41, 42. Let's inject voltage again and see what gets hot. Okay, increase voltage to 5 volt. I think this is the MCU. Okay, I've worked more on this device, and I found the problem. This is the problem. This is the MCU that should be right here. I took the MCU out, and if I measure now on this diode, before we have 40 ohms reading, and right now 0.9 kilo ohms. So the problem was this MCU that was getting hot. Let's measure in continuity mode. This look at that, no short, no short, no short. I'm measuring on these capacitors. I don't know if you can see. maybe on this one, that blue one that I took out. No short. So this is a no fix. We cannot replace that, or maybe we can, but it's not practical or economical to continue with this job, with this device. And one thing I can do is back up the software from the EEPROM memory, and then get another device with the same specification and numbers, and we can transfer the data from the EEPROM memory, but I will see what the customer wants. So that's it for this video. I'm gonna go and work on something else.